Hello and welcome to 7-2, which is multiplying powers with the same base. Our SWABAT, is to multiply powers with the same base. Some properties, actually just one for today. It is known as the power of a product property. The power of a product property. The name of it, not super important, but I do want you to realize that when they have the same base, remember that the base is the bigger number, the exponent is the smaller part, obviously. When they have the same base, like this A and A, then we're going to add the exponents. We're going to add them every time we're multiplying powers with the same base. Why it works? Well, let's look at this. Based upon this rule, when I multiply 3 to the 4th times 3 squared, I should, if the rule is right, I should get 3 to the 4 plus 2. So it should be 3 to the 6th. Well, let's see how and why that might work for us. 3 to the 4th is like 3 times 3 times 3 times 3, correct? Correct. 3 squared is like 3 times 3. So how many 3's do I have? 1, 2, 3, 4, 5, 6. 3 to the 6th. We can always expand it out if we forget this rule. But isn't it a lot easier just to add the exponents instead? Because we're basically adding 1, 2, 3, 4, 5, 6. Or I could add 4 plus 2 and get the same 6. Okay, let's put that into practice. Simplify each expression. I have 9 squared times 9 to the negative 8 times 9 to the 6th power. So just to take these two, I have 9 squared times 9 to the 8th. If I add them up, I'm going to have 2 plus negative 8 is negative 6 times 9 to the 6th power. And then these are the same base as well, so I'm going to add those, and I have 9. What's negative 6 plus 6? 0. We learned this in a previous lesson. What's 9 to the 0 power? 1. That's simplified. Now, one thing I do want you to know, this looks a little bit different, but it's not gnarly. I'm going to basically just multiply negative 5 times 3 first and give me 15. And then b to the 3rd times b to the 6th. They have a same base. Here's me. b to the 3rd times b to the 6th. Same base. So I'm going to add the exponents and get b. 3 plus 6, 9. 15b to the 9th power. Okay, your next one. Again, I'm going to just kind of like combining like terms. I'm going to do 6 times negative 4 first, and I get negative 24. Then I have a cubed times a. So I have 3 a's here plus another a here. I'm going to have a to the 4th when I add my 3 plus the 1. Remember that if they don't give you an exponent, there's a 1 there. And then you have b to the negative 2, b to the negative 2 times b to the negative 8. Well, if I add these exponents, negative 2 plus negative 8 gives me negative 10. And now, in my mind, I have an alert system. I get a problem with this negative exponent, so I'm going to go ahead and put this over 1. Now, negative 24, it's not an exponent, so I'm going to leave that as negative 24. A to the 4th, that's fine exactly where it is. I like it right there. This negative has to leave. If it's negative up top, I move it down to the bottom, and that's when it becomes b to the positive 10. Now, that is box worthy. Okay, onward. Looking at this problem, what do you see? What's in common? Good. 12 times negative 1, because if they don't give you a number, it's like a 1 in front, times 2. So here's where I'm at in my head. 12 times negative 1 times 2, that's negative 24. And then I have my m's. Well, how many m's do I have? This is m to the 1st times m to the negative 3. Here's me. M to the 1st, m to the negative 3, and then there's another m over there, times m. Remember, no exponent, I'm just going to add them. I don't know why I make that a negative 3, but it just says m to the 3rd there, so that's a positive 3. So 1 plus 3 plus 1, m to the 5th power. How about those n's? I have n to the 1st power here, n to the 1st. And then over here I have n to the negative 2, and there aren't any n's there. So I have 1 plus negative 2. That's negative 1. Then lastly, I have p. There's only one set of p, so it's just p to the 5th. Got a problem with this negative 1. I'm going to put this over 1. And I have negative 24. M to the 5th is fine. N to the negative 1, that's a problem. Moving it down to make it positive. P to the 5th. This is the easiest way to get rid of negative things, is to move it down. Only wish we could do that in real life. Can't. Alright, last two. Ooh, we have some fractions. I know you like it. Negative 4 times 2. The number's first. What's negative 4 times 2? Negative 8. Very good. Little fraction action for us. We have 3/4 plus 1/4. Yay for us, we already have a common denominator. 3 plus 1 is 4. The denominator stays the same as 4, which equals 1. And I would hate that if you wrote it and left it like that. So I'm going to write it as negative 8m instead of m to the first power, because that's kind of whack. Alright, last one, a little bit more fraction action for you. Let's do the numbers first. Let's get those out the way. So 2 times 5 times 3 times 4. Well, 2 times 5, 2 times 5 times 3 times 4. So this is 10. This is 12. 10 times 12 is 120. Not a bad thing. Sometimes we just need to do a little work off to the sides, and it keeps my work area clean. And then I have b to the 2/3. I'm going to write this out. B to the 2/3. I'm multiplying that by b to the 4/3. And I'm going to also group the t's because they're like terms. T to the 2/5 and t to the 3/5. Okay, that 120 is set. We're good with that. What about these b's? 2/3 plus 4/3. Same denominator, so I'm going to keep that at 3. And then 2 plus 4 is 6. I don't like that. But for this t, I have 2/5 plus 3/5. Sounds like I have a lisp. 5/5, because 2 plus 3 is 5. Now, what I didn't like about this, by the way, is of course that it's an improper fraction. 3 goes into 6 evenly. It goes into there 2 times. And then t, 5 divided by 5 is to the first power, but I'm not going to write that 1 there because no one needs it. There you go. Kind of helpful. If you look at this lesson and maybe even a previous one, what are some of the main things or main tips that you might want to give to someone for this one? Sorry, that's a little bit personal. Okay. All right. So thank you very much for joining me, and have a great day.